Good morning, class. So today we're looking at the solution of triangles, so the sine, cos, and area rule. Okay. So we're on exercise 10.4. No? Let's do the examples for. We're not on the cosine rule yet. No. What is this? This is examples for exercise 10.4, and the exercise 10.4 is on page 340. Fine. Okay, and the examples for this is on page 344. Okay. Okay, so now we're looking at the ambiguous case of the sine rule. Okay, if the size of one angle and the length of two sides, if the size of one angle and the length of two sides of a triangle are given, and the shortest side is opposite the given angle, then it's possible to draw two different angles with the same given information. This is why the combination is called the ambiguous case. Okay, you guys understand it, no? So if we are given basically an angle, and the length of two sides. The size of one angle is given and the length of two sides of the triangle. The shorter side is opposite the given angle. So if this is the shorter side, say that is the other angle that was given, then this angle here can be um, it can be acute, okay, and it can be obtuse. I think we did something like this already. Hmm? You don't know. Okay. But anyway, let's carry on. Note that the smallest angle lies opposite the shorter side, and the largest angle is opposite the longer side. Therefore, if the triangle contains an obtuse angle, the angle lies opposite the larger side. How many obtuse angles can you have in a triangle? A maximum of one. Okay, because angles in the triangle adds up to 180. So the smallest obtuse angle, which is 90,00001, you can't have another angle of that size bigger in a triangle. So then you're already going over 180. Okay. So again, the smallest angle lies opposite the shorter side, and the largest angle lies opposite the longer side. Therefore, if the triangle contains an obtuse angle, this angle will lie opposite the longer side. Any triangle will have at most only one obtuse angle. Consider the following examples. Okay, I think I did one of these. But anyway, so we're looking at the example on um, example 1 on page 344. The question says solve triangle ABC. People, if they tell you solve the triangle, what does that mean? It's calculate all the unknown angles and all the unknown sides. Okay. If AB is equal to 8 centimeters, which is lowercase c, AC is equal to 6 centimeters, and B is going to be 48. Okay. Working correctly one decimal place, we can draw the triangle in two different ways as shown in the diagram below. Can you see that, people? This can be an obtuse angle, as in diagram 2. C can be an obtuse, or C can be acute. Can you see that, people? Alright. So you say solution here, the side opposite the given angle is 46, is 6. The side opposite the given angle is 6. So as you can see here, the shortest length is opposite the given angle. Right, so in that case, it's going to be the ambiguous case there. So what did we say? We said we're going to use a sine rule. Okay, just to refresh your memory, when do we use sine rule? We have two angles and a side, or two sides and non-included angle. Okay, it has to be a non-included angle. Otherwise, we'll go into a different rule there. Okay, so we know that sine of A over A is equal to sine of B over B, which is equal to sine of C over C. Or you could have said A over sine A is equal to B over sine B, which is of course equal to C over sine C. Alright, do we have angle A? No. So we say sine of A over A, we don't have that, is equal to B sine B, which is 48 over 6, which is equal to C sine C is under over 8. Okay. So what can be calculated at this point? C. C can be calculated. Not so. So we're going to band that together and cross multiply. Okay? So that is simply going to be 8 sine 48 is equal to 6 sine C. Divide by 6 both sides. So sine C is equal to, on the calculators, 8 sine 48, close brackets, over 6 is u 0, comma 9901. Is that correct? 0, comma 9908, and of course the number goes on. So what we work out, as we said, we ask ourselves again, which quadrant we sign? Positive. So we sign positive. Quadrant 1 and 2. If it's acute, of course, it's quadrant 1. So we go off sign, shift sign of that ratio is going to get 82,25. So C is equal to 82,25 degrees. Or in card we get into quadrant 2. The angle C is equal to 180 minus 82,25. So 180 minus, will give you 97,75. You see, if the angle is acute, like as in the diagram 1, then the angle C will be acute. Okay, otherwise it could be an obtuse angle as well. Okay. So what do I do from here? I can calculate angle A. Okay, so we can calculate angle A. How do you calculate angle A? Angles in a triangle, not so. So you're going to say 180 minus 82,25 in the case of it being acute, minus 48. Somebody work that out fast. Sorry? 49,8 degrees. Otherwise, it can also be 180 minus 97,75 minus 48. Gives us an angle of 34, you guys understand? Have I calculated everything at this point? No. What must still be calculated? Angle? And we've got A now. So I can calculate lowercase a. Not so. Okay? So I'm going to go with this here. So we're going to say sine of A, which is 49,8 over lowercase a is equal to sine of 48 over So what do I do? Cross multiply again. Okay? So it's going to be 6 sine 49.8 is equal to a sine 48. You guys following? You understand? Right, so what do I do now? Divide by sine 48 both sides. So it cancels. So a is equal to, work that out, 6 comma 2 6. Or on the other hand, we will use an angle of 34 comma 23. 34 comma 23 over lowercase a is equal to sine 48 over 6. Sorry? Is something wrong? We cross multiply. So 6 sine 34 comma 23 is equal to a sine 48. It cancels, so a is equal to 4 comma 5. Units are divided. Alright, you guys understand? So with that, you should be able to do exercise 4.3. Okay. So then we're going into the cosine. Alright, at this point I'm going to stop the video.